Good afternoon, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic reflection of uniform plane waves at a plane conducting boundary. And this is my flow of presentation. I am going to discuss about what is a uniform plane wave first, and what is a normal incidence, and what is a dielectric boundary, what is the boundary conditions for this criteria, and what is this reflection coefficient and transmission coefficient, and finally about the standing waves and applications. First, what is this uniform plane waves? In case of uniform plane waves, electric and magnetic fields are uniform in plane waves and it will be perpendicular to the direction of propagations. And the field will be varying only along the direction of propagation. So, here in case of this uniform plane waves, we has both electric and magnetic field. It will be uniform in a plane perpendicular to the propagation, and there will be no variation in perpendicular planes, and it will be varying only along the propagation direction. So, variation in propagation direction is only possible. And next one, what is a normal incidence? In case of normal incidence, when a wave strikes at the boundary at zero angle, then we call it as a normal incidence. It simplifies the analysis since no tangential components change will be occurring over here. So the wave will be striking at the boundary at the angle of 0 degree. And next one is a dielectric boundary. It is an interface between the two conducting medium. Each medium will be having its own permittivity and has its own intrinsic impedance. Permittivity is represented as epsilon. Intrinsic impedance is represented as eta. So this permittivity and the intrinsic impedance will be different for each and every medium. And next one is a boundary condition. In case of this criteria, the tangential component of E and H are continuous across the boundary. And it is very useful to derive this reflection and transmission coefficient for this criteria. So this E and H tangential, which is nothing but E tan and H tan, are continuous. And using this condition, we can derive this reflection coefficient and transmission coefficient. So what is the special cases involved over here? If eta 1 is equal to eta 2, eta is nothing but it is an intrinsic impedance. Eta 1 is a intrinsic impedance for medium 1 and eta 2 is an intrinsic impedance for medium 2. If both are equal, then there is no reflection of waves occurs. If eta 2, which is nothing but intrinsic impedance of medium 2, if it is greater than eta 1, which is nothing but intrinsic impedance of medium 1, then nearly total reflection will be occurring. So, equal refractive indices, different refractive indices. If both are equal, then it is an equal refractive indices. If both are different, then it is a different refractive indices. Both are equal, no reflection at all. If both are different, then there will be a reflection will be occurring. Nearly a total reflection will be occurs. Most light will be bounces back. And next one is a standing wave. What is a standing wave? If there is an interference between incident and the reflected waves, then it leads to the standing wave pattern which will be occurring in the medium 1. So the wave, what is this incident wave and what is this reflected wave? Wave traveling towards a reflecting surface, we call it as an incident wave. The wave bouncing back from the reflecting surface, then we call it as a reflected wave. So if there is an interference between this incident and the reflected wave, which leads to the creation of the standing wave in the medium 1. Finally, what are all the applications of this interferences and all? First one, in optical fibers, high-speed data transmission over a long distance. Second one, radar system, the object detections and tracking for critical applications is possible. In wireless communication, interaction without the physical connection is possible. And in microwave engineering, design of microwave systems for efficient signal strength is possible. So all these lead to the efficient signal transmission. And this is the summary what we have discussed so far. We have discussed what is this normal incidence, what is the dielectric boundary, and what is this incident wave, reflected wave, and what is the reflection coefficient, transmission coefficient, what is the condition at the boundary, and finally about the applications. And these are all my references. Thank you.